Hello everybody. Our task today was to think of a complete system for electric bicycle to recharge power while going downhill. Our team Rimantas Baranauskas, Andrius Arlauskas, Andrius Juknevičius and I, Marius Karotkis.
Here you can see our vision of the system. We designed it to be like a module that you can attach to the already existing e-bike. It can be an e-bike by design, or it can be an e-bike that you transformed, like it's an ordinary bike and you transform it to be an e-bike. The module is attached to the frame of an e-bike. You can attach, you can detach it. It is integrated like that. We've analyzed the current situation. We are using the existing e-bikes. On average, the most important things, that's the weight. It's 25 kilos. The top speed is somewhere roughly around 32 kilometers per hour. And the maximum distance you can travel with an e-bike is somewhere around 56 to 95 kilometers. According to the task at hand, we've designed our system to work like this. Everything starts with you riding an e-bike. First of all, an e-bike system should be turned on, and next comes our charger system. If it's turned on, the charger is constantly on a standby mode, and we are monitoring the z-axis of an e-bike. If you are riding the downhill, the charging will be activated. At the same time, you can decide to turn on the acceleration like in the task, and at that time our charging system will be killed down and an e-bike will perform like just an ordinary e-bike.
This is the component list. As you see, it will be a super lightweight. It will weigh around 300 grams and the bike is like 25 kilos, so you won't notice the difference. It is very power consumption friendly because the device will use around 15 milliamps of the power, and the average battery is like 1000 ampere hours, because we are connecting our small device to the external battery that you will already have on your e-bike or your e-bike kit. So our device can last for around 6 or 7 years in active mode. And this is the device schematic. At 1 and 4 you can see the wheel and battery. This is basically just a few wires that connecting the real device, and we are interrupting those two wires and connecting our device with the hubs. And our device consists of the microcontroller that is quite cheap and has some analog inputs and digital outputs, so we can control our relays that will activate our module or turn it off. The main thing is the gyroscope that measures the axis, the z-axis of the bike, because if you're going downhill, your bike will be a bit lower front and higher back, and basically if it's like 5% of the leverage in the road, our system will activate the charging because it was in the task. Of course, there is a power button to turn the system on or off. It's your optional thing, but basically it should be on. The voltage regulators are used because the battery on the e-bikes are around like 40 volts, and our microcontrollers sensors and relays are using 5 volts as usual in microelectronics. And there is from the bike to the battery connection that we control based on the relays, that we use the wheel that has the motor already inside, and it generates AC current, the alternative current, so we use the rectifier and voltage regulator to create that chain so you can charge the battery directly. And this is the system, the kits for the e-bikes that's already for the purchase. It can be from $100 to a few $1,000s, and this is the part where we attach our small device, because all those parts are connected by hubs. And this is the place when you can easily connect to basically all around systems that are already created. And our device will provide the charging downhill feature. And if the bike is the original e-bike, not without the kits, you can also just take your bike to service, take our little device, and the mechanics will just cut those few wires that are from the battery to the wheel, and with the simple hubs they will connect our device. It will not interfere with the original system, just control either it's on or off.
And here you can see the conceptual design of our system. All the component models are created according to the real components which we can buy today, and all of them are fitted in a small box and mounted, attached to a holder. The holder connects to the e-bike frame, and that's all. Here you can see the efficiency of our system using an e-bike, and as you can see, if you have a downhill time around 10 minutes, then you have plus 10 kilometers in your mileage. And for example, in Denmark, it's lots of flat terrains, so probably you will have that downhill time. But if you have around 60 minutes of downhill time, then you would increase your mileage of around 50 kilometers. And of course, it should be mentioned that all the calculations is based that the average speed of the e-bike is around 20 kilometers per hour. Of course, the economical justification. All the components are bought today, most of them from the eBay, and you can see in total that the price is quite steep. But this is a prototype, and if you would like to commercialize it, the price will go down very fast.
So, to sum up, we've made a system that is easy to install and maintain. Like if you break it, you can replace it and it won't affect your bike. It is compatible with all already existing e-bikes. It's just a module that you attach to the frame of an e-bike. The commercial price of a system is relatively low. We designed it using widely used components that are available right now, and well, the power consumption is also quite low. So, forward to victory with chargeback. Questions?
Yes, stop. Okay, I understood that your user interface is rather limited, that you are not giving too much information to driver. What kind of status you plan to how you can plan to inform a driver? What is the status of batteries and what else? I didn't notice such kind of element.
I don't understand what information do the user needed to use, because all the battery life and how much battery does he have is on his e-bike. Because this system is, as in the problem, we created for recharging, and it is compatible with e-bike you can buy in every store, and with e-bike you can make from the kit that you can buy.
Okay, so I understood that you plan to use the display which is on original bike and your system is just separate.
It is separate.
The recharging.
Yeah, it is separate, but it doesn't use any displays. All the displays, for example, LEDs that would show the battery level, it's on the e-bike battery, so we won't need that if you are talking about that. Correct me if I'm right.
I think that this microcontroller has a lot of information about the system, how it is behaving during the lifetime. Have you considered that this kind of information might be useful for user?
Yeah, but you see, if we would use that to display the information, for example, a small LED screen in front of the driver, then yes, we can provide that information to the driver, but it will consume more power than it is needed, for example. But because this problem is to charge the system of the e-bike the most as we can.
I want to add that the e-bike will be the same as it is, just with a new function that it will recharge going downhill. You don't need to know about it, you just turn it on and it affects all the time when you are going downhill.
Thank you.
I have a question. How the energy flow back to the batteries, and is going through your controller? No, it just gives the controller information that now we are going downhill and
Yes, controller controls, you see, by going downhill, controller knows it by the gyroscope, and it converts a bit the circuit from the wheel that generates the power to the battery. So, because the wheel generates too low voltage, so it has to be regulated to the level that battery can be charged. So this is what our controller does. In task, it has to be when you're going only downhill, not all the time. So that's what we did.
so it levels just rises voltage that comes from the generator a little bit higher so that it can charge the battery.
Yes.
And how you disconnect controller or what kind of motor you're using? Because usually the power goes through the controller, through the thyristor switches.
We're using the default mechanism, the default motor that's already within the e-bike. Nothing additional. Because it's a battery and a motor, and basically just few
Okay, you have
wires.
direct connection from
Yes.
battery to...
And we are interrupting that connection. And because just this ordinary connection is with not enough voltage to charge it back.
But basically in this system you don't have the possibility to control the speed. You don't have just a switch that I understand at the moment for the motor. That you switch just the motor, battery voltage on the motor and it accelerates as much as it can. You don't have
It's
to
not
control it.
accelerating.
Yeah,
It's
but
charging battery.
Yeah, but in if you're looking other way, you are saying you have the direct connection from battery to the motor.
Yes.
Yes. And you have possibility only then you have switch that switches it on and it
There is
goes.
a button on the wheel.
show the flow chart. I think it's very simple because when you press the acceleration button, everything goes like from the start. The charging system is on the monitoring mode, yeah, but all that system for charging is off until you release the acceleration button and you're going downhill.
Okay.
If you press the acceleration going downhill, our system stops and you just use as a normal e-bike.
The system is used just for that,
Okay.
that you
Yeah.
could use the motor, in-wheel hub motor, as an alternator mode. In alternator.
One side question, can you charge the battery when you are going uphill, just pedaling? Why not?
Yes, you can, but the task was while going downhill.
Okay.
It was really
Thank you.
difficult.
But why did you choose a gyroscope?
Because
Why not just leveling device?
gyroscope
It's
gives.
much cheaper.
Gyroscope is like $2. That's
Yeah, so
sensible.
just leveling system is even cheaper.
Yeah, but see, some of the leveling systems can provide the output we need for the controller.
Okay.
Thank you for your questions. Thank you, Kaunas.
Thank you.